Okay. We're going to be solving now. So remember, solving, there should be an equal sign here. I'm on the homework. We're good. We'll start over. We'll start over. Okay, warm up. You did this on your homework, and you did it on your orange or yellow sheet, the graphic organizer. See if you can go ahead and write these rules out based off of them. If you don't know them, get out the yellow sheet that we did together. Okay, that's super important because it's going to help you drive through this whole chapter if you get stuck with the rules. I would recommend having it out just as a reference for you. Obviously, if you don't need it, great, but if you do, it's a wonderful tool. See if you can fill those in. Hopefully you can, and it'll be quick. Yep, go.
Okay. Product rule, log base b, m plus log base b, m.
Perfect. Anyone else? Go ahead. Beautiful. Fantastic. Go ahead, Tatiana. N log base b of m. Okay. Questions on those? You were doing a very good job with it. I know some of them were hard on the trail, but you were doing a good job. Okay, now I want you to take a second and see if you can do these. Okay, again, take your time. Well, not too much time, but see if you can break it apart. It's going to be log something. Try to get you started here. Help you with the first step.
I got it.
Want to write it?
I don't think mine could have hurt.
Wait.
So like,
because you have to add.
36 divided by 2.
so how did I write it?
It's divided by.
Because what minus is divided.
Yeah, no.
Okay.
Yeah, but then plus the 3.
But then times 3. Because
Okay,
the
that's
plus
what I thought.
it's right here if you need it.
So what's 36 times 3? Wait, what's 36 times 3? Oh, you multiply the whole thing by 3?
It's 48. Okay. Well, 36 times 3 divided by 2. Or it depends on how you want to write
Okay,
it.
I'll just do one of those.
Yep.
And then it equals log base. Yeah, I know. I was gonna like do that. Wait, what pen? Where's the pen?
Right there in front of you with the orange smiley face.
Oh, wait. I don't want to screw this up. I'm gonna look at yours.
Go ahead.
Because I don't have much work.
You might want to do the first one.
Yeah. I like this. What's up, Hubert?
You got it? So he's going to bring the 2 up. And you get 6 squared.
You took 6
Which we
squared.
all know is 36.
36. Subtracted by log 16 to the one of those.
The 4th root. So that means 4th root of 16, which we know is 2.
2 of log 3.
Just drop it. All right, good.
Boom.
Awesome. So Mike gets to take it today. So
Wait.
6 squared was 36. That's how we got that. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 one more time gets me 6. Wait.
Yeah.
Yeah, gives me 16.
Yeah.
Okay, remember subtraction means division. So
So it's down
36
there.
divided by 2, and then times 3, which gives me 48. You could have wrote it differently. Yes. You want to explain?
Oh yeah, I'll explain. Okay. So you know how like the numbers out in front, it's being multiplied by the
I
log.
got log 16.
That is the same thing.
Yeah, it's the same thing.
So the
It's like-
fourth root and the, sorry, go ahead.
You know how you have like the little root? Well, like the denominator of the fraction will be like what you're square rooting or like rooting to. So you do like 4 root. Yeah, I don't know how to say that. But
Yeah, good, you're good, thank you.
Yeah.
Okay, still very
I can be a
good.
math teacher.
That was good. Okay, so the question was, this fourth, 1/4. If you would have done 16 to 1/4 in your calculator, you would have gotten 2. Or you should just know that when it's a fraction like this, it really just means a fourth root. Like 1/2 is a square root. 1/3 is the cube root. Okay, so that was your answer. Now expanding, I think, Katie, you were going to do this one, right? Geez, that's been too. Okay.
Whoa. Uh-oh.
Whatever you do, it will be calculated. Okay, so Katie brought the 1/2 in front, and she is right because 1/2 really means a square root. Okay, then because both of these pieces are in the denominator, we're subtracting both of them. The 5 stays here. So many times we get asked, well, why isn't the 5 in front? It's not a power. It's called the power rule. It's just 5. It's 5 to the power of 1, technically, so 1's in front. Okay, and then the 3. Very good job, guys. All right, cool. So if you could do that, we'll be fine today. So when we are solving, it's when we have equations. What we're going to do is we're going to solve for them, okay? And you're going to be able to do that very well. So first we're going to condense if we can. Okay, we just practice that. If we can condense, great. We have to do that first. If not, we can move to step 2, which is the 1-to-1 property. Okay, so if log base b of m is equal to log base b of n, then we have m is equal to n. Okay, so what's cool about the 1-to-1 rule is they basically cancel. So like if I had 2x plus 1 equals 2x, you can cancel the 2x's because they're on both sides of the equation. They're going to cancel out. Okay, so same thing here. The logs will cancel in this situation. But it has to be one log equaling another log. Okay, and that's at the same base. So in this situation, do I have one log equaling one log? Are they the same base? Okay, goodbye. And we're just left with 1 minus 4n is equal to 2n plus 43. Please solve because you know how to solve from here. Or you should be able to know how to solve. Get it right, you get a ticket. Get it right, raise your hand, we'll give you a ticket if you get it right.
I got it.
Yeah.
Oh, can I do it?
Yeah.
Miss Sarah?
You got one already? Got one? Careful with that, okay. So it's very common. Is that a positive? A lot of people got 21, it's okay. Done?
Yeah.
Yes.
Oh my God.
Okay. So Is that a question or? No. Okay, when you solve this, a lot of people made this error, that's okay. Remember, you get all your letters to one side and all your numbers to the other. So I would subtract 2n here. That would disappear, and I would get negative 6n. Okay, if I owe you 4, I took 2 more from you. I now owe you 6. But then I also subtracted 1 over, and that's why I got 42 on this side. When I divide, n got me negative 7. Now, we do have to check for extraneous solutions. That just means that we have to check and make sure that the argument is not negative in this situation. Okay, because that's where the n is. You have to ask yourself, where is the variable? The variable is in the argument. I can't have negative arguments. If it was in the base, I can't have negatives, and what else can't I have? Not 0. What can't the base be? Someone said yes, 1. Okay, so remember from way back when the base b cannot be 1 because it wouldn't be exponential. 1 to a million power is just 1. It's not growing exponentially. Okay, so we're looking here. We're saying, oh, we're in the argument. That means I can't have negatives. But let's look. When I plug it in here, it changes to positive, right? We're good. Okay? If I plug in negative here, I get negative 14. What's negative 14 plus 43? Is it positive or negative? Positive, so we're good here. Okay, so you have to check to make sure because in some situations it would not work. Okay, so remember you can't have negative arguments. You need to check for your bases too, which next page we have base ones. So we'll look more into that when we get there. Okay, so let's look at this next one. Okay, do I have 1 log equaling 1 log? No, I have 2 logs equaling 1 log. But what do we know we can do? Compress, kind of condensing, yes. Yes, because of this negative, I have to divide. So I have log base 4 of 68 divided by 4 because we condensed. That was our first step. Hold on. Which, yes, it is 17. So I'm just going to simplify one more time. For the sake of notes, I'm just writing it all out. Some of you will be able to skip some steps here in the future. Do you have questions on that part? You sure? Ooh, not 1, 11. Now do I have a log that's the same exact base equaling the same exact base on the other side? Yes, so goodbye, they're gone. And now I'm just left with what was there, the arguments. Here they are. And now we're down to something easy. 17 equals 3n plus 11. Get it right and you get a ticket. Bam. Rocket science. You are.
I got it.
Good, you're doing fantastic. So, again, moving a little faster in the solving part because we know how to solve. I subtracted 11. Okay, I got 6 equals 3n, and I divided by 2, and n was 2. Okay, so we just go back and we check. Again, where is the variable? What piece is the variable in right now? We have bases, we have arguments, we have exponents. What's going on? Where's the variable? The argument, there it is. So I can't have negatives. So when I plug in 2, am I going to get a negative number? No, so we're good to go. Okay, so you always have to check that. We can't have negatives in the argument. Let's look at this next one. Yes, it's ln, but that's okay because that's the same thing as a log. You need to get used to it. There's a lot of phones not liking that. I will take them. Here's one away. Okay, this stuff is not easy enough for you guys to just not pay attention. Okay, what does this negative mean? Division. So I have ln x plus 10 all over x. Questions on that part?
No.
Okay, equals. What am I going to do on this side now? Multiplication.
Sorry, where did the X?
Good question. So here, when I do division, I take the arguments. So I have x plus 10 all over x. Here, I take the arguments and I multiply them now, and I get ln of what? 6, because I multiplied them together. Good question. I'm glad you brought that up because I was going to ask it to you anyways. So this x is applying to both of them. So if you did that, you'd have 1 plus 10 over x. And that gets a little complicated. So I would not recommend doing that. Because if you do this, but you still have 1 plus 10 over x then. Because the x goes to both of them. Okay, so be careful with that. Don't do that. I would not recommend it. So we erase it. Okay, now, ln is still log. So what can I do with both of them because they're the same on both sides? Cross them off. I have x plus 10 all over x equals 6. Now, there's a couple ways you can do it. You can cross multiply because technically there's a 1 under here somewhere. Okay, or you can just multiply by x on both sides. So I'm going to multiply by x on both sides here. That goes away. And I get x plus 10 equals 6x. Go ahead and solve from this point. Is somebody done?
Right over here.
Good, you're killing it. Cool. All right, throwing things.
No.
Okay, thank you. All right, cool. So you got x equals 2. I think everyone did a fantastic job there. Do you have questions on why we got x equals 2? Now we got to go back and check. Look, where is the variable at? What do we call these things? They're arguments. So when I plug in 2, I get 2. When I plug in 2, I get 12. I'm good. Remember, they have to be positive in the situation. Do you have questions on that? Okay, let's do a complicated one, and then we'll move to the back. Let's see which one I want to do.
Wait, can we do D because I already
That one's a little easier than some of these, so
You want a challenge?
I want to do F. Okay, because the other ones are pretty similar. I mean, I'm not really worried about those if you can condense. All right, so we have to condense first. So on this side on the right, I have 2 logs, so I have to do something with them. Yeah, so that you could either skip a step or not. I'm not going to skip a step just for the sake of these notes. So I have x times x plus 3. Now, Huber was like, oh, it's x squared plus 3x. That's fine. If you got that already, perfect. If you already in your head is like, oh, I know I'm just going to distribute, fine. But I'm not going to do that here. What happens to the 2 out in front? Very good, it goes to the top. So I have log, ooh, that's not a log, log x plus 1 all squared. At this point, what can I do now? Cross off the logs. Now, here we go. A lot of people make mistakes here, so be very careful. It's not x squared plus 1. What do you have to do? Very good. You have to multiply the x plus 1 times the x plus 1. Very good. I'm going to write it all out for the sake. Well, let's distribute this one to make it easier. X times x is, and then x times 3 is plus 3x. Very good. I'll erase this to make it the same color. Okay, now, this is double distributing, or just distributing, or FOIL if you know it as FOIL. First, outer, inner, last. So I'll color code it here. First, x times x. Very good. And then I have x times 1 in green, plus 1x, or just x. And then in blue, I have x, wrong one. 1 times x again. Good. And then here in purple, 1 times 1. Very good. I'm going to bring everything else in black so that you know that nothing changed. Now, we kind of already talked about this in terms of logs, but look at this equation. Do you notice anything?
Yeah.
What? Kind of. I have an x squared on both sides. The moment you have something on the left side that's the same on the right side, it disappears. Because technically you'd subtract it and it would go away anyways. So try to get used to when you're solving that if you have the same exact thing on each side, they go away. Yes, oh, that's my hand. Well, now let's simplify. What's x times x? 2x. Careful, not multiplying. Okay, solve. Rapid fire solving. It should be very easy. It's just that new step that we're learning. That new first step. Okay. Look at you. Yep. Go. Get one?
No, I didn't get one. I got one. No, but I got the answer. Yeah, but
Yes.
I got one.
Did you get it?
I didn't get the ticket.
Cool. You got one. You're rocket scientists, geniuses, mathematicians, whatever you want to call it. Okay, x equals 1. Now we have to check it. Okay, we have the x in the argument here. Is 1 going to make any of these negative? No, so we're good to go. Maybe put a check mark so you know that you checked it. Okay, flip the page, please. Factoring will be coming back here soon. It's okay. All right, here we go. Now we have a different situation where I have a log equaling a number. Okay, so if we have a log equaling a number, there's something that we know how to do because we learned it last chapter, or was it this chapter? I don't remember. Where you have to convert to exponential form. Okay, so first condense if you can. Nothing to condense in the first 3 here. And then write in exponential form. Obviously, check for extraneous. Remember, I'm going to put here extraneous solutions. What can't the base be? 1. Okay, or negative. So, or negative. You can just say, or it can't be less than 1. Okay, and then what can't the argument be? Can't be negative. Very good. Okay, so those are the 2 things you need to be looking here. This is when it starts to, you start seeing extraneous solutions, is when you have a log equaling a number. Okay, just kind of how we talked about that when we were doing, what were we doing? I don't even remember. It was some chapter ago. Okay, so let's look at A. Let's convert. This is when we had the heart. X cubed is equal to 8. There's a couple ways you can do this. You can take the what because it's the inverse of cubing something. What's the inverse of? You can do cube root, or you can just know what to the 3rd power gets me 8. It's going to be 2. Yeah, we did this last chapter, but now we're solving. Okay, we want this answer. Usually, when we guys tested you out, we asked you for this. Now we're asking you for the base. Okay, so we asked you for the exponent before, and now we're asking for the base. Again, look, when I plug in 2, it meets my requirements, my restrictions, so I'm good to go. I'm going to put a little check mark because we checked it. Okay, remember the base can't be negative or 1. Let's do it again. 4 to the negative 2 is equal to x. Well, here's where a lot of people say, oh, it's negative 16. No, what is it? It's 1 over 16. Very good. Because, again, the negative exponent just brings it to the bottom. That's all it does. It does not make it negative. Okay, when I plug it back in to my argument, the only restriction is that it cannot be negative. Is it negative? No, so I go ahead and check it off. Good to go. Whoop. Okay, let's do it again. Actually, no, I want you to do this one. Remember what your square roots are, your cube roots are. How would you write that as an exponent? That kind of thing. Boom.
got it.
Yes. What? How would I get to way I can get on it. Hard to explain because without giving, like how would I? If I'm going from big number to Okay. Half and half here. We got a lot of good answers. Okay. You get 9, 81. Whoopsies. 81 to the x equals 9. Now, whenever you go from a big number to a smaller number, you're going to be some type of fraction because this is the only way. You can only go from a big number to a small number if you're going to take the square root, the cube root, the fourth root. What am I going to do in this situation? 1/2, which is a square root. Very good. Now, this is the exponent. Exponent could be anything, so I'm not really worried about it. Okay? All right, here's where it gets a little challenging here. I'm going to do a couple more. I want to figure out which ones I want to do here first. I'm going to do D. I'm going to do G. And I'm going to do I. Okay, so I got 3 more with you. All right, here we go. Again, this is pretty easy right now because we're really not doing anything too difficult. Let's go ahead and convert. 2 to the 6th power is equal to x minus 4. Okay, I mean, just because you have 2 to the 6th powers doesn't mean you don't know how to solve this. What is 2 to the 6th power? 64, very good. And then my last and final step is to add 4. Oh, what is x equal? Good. Okay, now, remember, you have to check it because sometimes it won't work. In the situation, it will. But look, we're in the argument. It can't be negative. If I plug in 68, I'm good. I get 64, so we're good to go. Okay, you can always check your answers by actually plugging it all in. Okay, let's do 2 more. Here's where it gets tough because we're going to have to factor. We're bringing it back. I know you like to factor. We have to condense them first. Very good. We're going to G. I'm skipping around so that you guys have time for your homework and can ask questions. Whenever I have adding, that really means doing what with the arguments? Multiplying. I have log base 6. I'm just going to distribute because I'm starting to get more advanced with you guys. I get x squared plus 9x. Very good. Equals 2. Questions on that part? Give you a second to write. I see a lot of hands writing, so I don't want to go too fast. Now what do I do? Yeah? I do a little hard thing. What is that called? Write in exponential form. So 6 squared is equal to x squared plus 9x. Very good. Oh yes, this is where the factoring comes in. Because look, I have a squared term. I have a linear term, just one, and I have a number. Whenever you have that, you have to factor. So I have to subtract the 6 squared over, what is 6 squared though? 36. So I'm technically going to subtract 36 over, and that will cancel. I get 0 equals x squared plus 9x. Now here we go for those factoring people. I'll write it out for the first time. what multiplies to negative 36, but also adds to 9? Very good. 12 and negative 3. So I have x plus 12 and x minus 3. We are going to get 2 answers in this situation. Very good. This guy gives me x equals negative 12. Oop, that's not a negative. And this is going to get me a positive 3. Now, why are you saying it won't be right?
Because you can't.
Yeah, I agree 100%. So this is gone. And let me explain why. Because I'm sure a lot of you were like, whoa. You can't, well, you can have a negative answer, you just can't have a negative argument. So what I mean by that, when I plug this in, if I just like come up here for a second, and I plug in negative 12, that's going to give me negative 3. I can't have a negative argument, so it's gone. Okay? Maybe write that down so that you remember it produced a negative argument. Well, I think someone told me that there's no E in there before. Correct my spelling, whatever it's wrong, please. This last one is pretty much the same thing, except we have a different base. What is the base of this log?
1, 10.
Yes, 10, okay? I know it's hard to remember all of these rules. The square root has an imaginary 2 in there, but this guy technically has a 10. So be careful when you're working with them, and that's why I wanted to make sure we went over it. So I have, to condense it, what do I got to do with these 2 arguments? Multiply or distribute. So I have log base 10. I'm just going to write that because we're going to have to convert it anyways. And I'm going to distribute. X times x is x squared minus 3x equals 1. Okay? I'm not going to do anything here because you guys know how to factor. But I do want to just take 1 second and go back up to this one, just in case you get one on your homework. Question on this. What is ln? Log base what?
Well, you would 2. Bring over. That's
10.
log. Natural
4.
log. Guys,
Wait, 0, 0, 0.
natural
I
log.
said 1.
ln is equal to the log base something.
E. Thank you. Please, we're going to do this one only because I want to make sure that you get this.
You got it.
I looked at it.
Okay? Here. Now, what can I do to both sides to get rid of this 4? Yeah, I heard it. Divide. Now, just because you have this E doesn't mean you can't do it because you have a calculator that will help you. Okay, you have an E button. You can do E cubed is equal to x plus 2. Well, get out your handy calculator and put that in. Okay? 20.09, good. So I have 20.09 equals x plus 2, and then I subtract 2, and I get x equals 18.09 something. Okay, so I wanted to write that one out for you in case you needed it, because sometimes we get confused. Remember, you have a calculator that tells you, yes. No, that's the common law. So this